Now that I've given you an overview of the structure and functionality of the PrimeCheck client, let's go ahead and take a look at its implementation. In this video, you'll understand how the PrimeCheck client is implemented to send and receive HTTP GET requests and responses both to and from the PrimeCheckApp server. As usual, you can find the implementation available here in the link at the bottom of the slide. We're now in the IntelliJ project for the EX1 example, and we're going to take a look at the contents of the client package, in particular the PrimeCheckClient class implementation. This client uses Spring WebMVC features to perform synchronous remote method invocations on that PrimeCheck controller web service we looked at earlier in order to determine the primality of large integers. And as we'll see, these invocations can either be made individually or in bulk, as well as processed sequentially or in parallel using Java streams. If you take a look at the PrimeCheckClient class, you'll see that it's got a component annotation, and that is used to allow Spring to automatically detect so-called custom beans. And Spring does this by scanning the application for classes that are annotated with the @component annotation. It will then instantiate them and then inject the specified dependencies into them without programmers like you or me having to write any explicit code. And let's see an example of this right off the bat. If you take a look down here, there's this thing called a REST template, and that's auto-wired. You can see it's a field called mREST template. And if you go over here and look at the components class, you'll see that it indeed has a bean that has a getRESTTemplate factor method that will return a REST template. And so Spring is smart enough to find that particular bean and then use it to initialize this field. That's the REST template field. There's also another field here called mBaseURL, and that is going to be indicating the location of the server. You can see here it's going to be at localhost port 8081. Now, a production system, of course, wouldn't hard code it like that. It would use some kind of name service or discovery service, but we're just doing this to make the testing easy for this example. Let's now go take a look at the two methods defined in the PrimeCheckClient class. There's one called test individual calls, which, as the name suggests, will make the calls one at a time. And then there's another method called test list call, which will make a single call that will pass all the prime candidates over as a list. So let's take a look at test individual calls first. What it's going to do is it's going to send individual HTTP GET requests from the client to the server in order to check whether the contents of the prime candidates list are prime or not. And it also takes a Boolean parameter called parallel, and we'll see how it's used. It's used in a very interesting way. It's used by the client to decide whether to run the test individual calls functionality sequentially or in parallel. So let's take a look and see how this works. We take the prime candidates list, turn it into a stream of integers, and then, depending on whether the caller passed true or false to us, we convert ourselves to a parallel stream or not. And then, once we have that stream, which is now parallel or sequential, we then apply mapping behavior to each of the elements in the stream, and then we collect the results into a list. The main thing to focus on here is what the behavior is for the map call. And you can see here, it takes each prime candidate and it goes and it makes a GET request to the server. So let's take this and kind of break it down a little bit. You'll note before we make the GET request, we first make a call to a helper method called MakeCheckIfPrimeURL. And that takes the prime candidate, and what it does is it goes ahead and takes the base URL, and then it adds the checkIfPrime string to that. So that's kind of indicating which endpoint we want to handle this on the server side. Then we go ahead and take the prime candidate first as a string and then as the actual value, and we concatenate all those things together to make a request URL. And that is what we're going to use, or what more specifically the REST template will use to invoke the operation on the server. So that's what is getting returned from MakeCheckIfPrimeURL. So we then take that result, the REST template, which is going to be how we contact the server, and then a third parameter, which is the type that we want the return value to be. So it's, in this case, it's an integer. We want to get back an integer, which is either going to be 0 or the smallest factor if it's not prime. And then we're going to call a helper method I wrote in my web utils class called MakeGetRequest. So here's what MakeGetRequest does. It takes the REST template, the string URL, and then that class that we passed in, and it uses the REST template by invoking its getForEntity method, passing in the URL, and then also the type we want the return value to be treated as. And getForEntity, as you might imagine, ends up doing a GET request or sending a GET request using that URL to contact the appropriate server, which in this case is localhost at port 8081. And then it passes in the parameters that we gave it, which would be the checkIfPrime string followed by the particular prime candidate we're looking at, all encoded as a string in the URL. And then when the results come back from the server, it converts it into the appropriate type here, which in this case was an integer. And then we take the result of this thing and we return the body of this entity, which will come back as an object of type T, which again, in this particular case is integer, although I wrote this method to be generic, so it could be used for other example applications as well. So that's how we get each of those requests, each of those prime candidates turned into requests that will then run on the server. So you can see here there's going to be a request for every one of the elements. So there could be a lot of calls, remote method invocation calls made, but we're kind of speeding things up potentially by being able to run this stream in parallel, which is a very convenient way of taking advantage of thread pooling on the client side without having to spawn a bunch of threads ourselves. And then the final results are, as I mentioned before, collected into a list and returned back to the caller. Now that you've seen how we can test individual calls, let's see how we can send everything in one fell swoop using the test list call method. That takes the same parameters that test individual calls did. It takes a list of prime candidates and a Boolean parameter, but it uses those in very different ways. So let's take a look at what it does. The first thing it does is it takes that list of integers and it's going to convert it into a comma-separated string containing the string representation for each integer in that list. So let's go look at that method. This method, which is also designed to be generic, and it's part of the web utils class I wrote, it takes the list of type T, converts it to a stream of type T, and then it uses the map intermediate operation to convert each of these elements of type T into a string representation of that element. So in this case, it would turn the integer into a string. And then it takes each of those strings and it joins them together into a single comma-separated string using the joining collector, using the comma as the separator. So what comes back from this is basically a comma-separated string that contains the contents of the original list. Well, what we then do is we use that string that we created and the parallel flag that was passed in, and we call another helper method that's defined in PrimeCheckClient called MakeCheckIfPrimeList URL. So let's go take a look at that. So that takes that string of integers, the Boolean flag, and then it's going to create another request URL, starting with the base URL like we did before. It passes in the checkIfPrimeList string. That's going to indicate the endpoint handler method we want the server to run in the controller. Then we're going to go ahead and add the string of integers, giving it a name so it can be mapped to the appropriate parameter in the controller on the server side. And then the last thing we do is we put in the contents of the Boolean flag, also indicating that its name is parallel, so that'll appropriately be matched on the receiving side. So that's how we get our string for sending everything over in one fell swoop. So this could actually be a fairly large string, depending on how many integers we're trying to use to check for primality. So we take this request URL, and then we're going to call yet another method in web utils. This is called MakeGetRequestList. And as you can see, it's passed the REST template, it's passed the request URL we just made, and it's passed what it wants the return type to be from the REST template call. In this case, it's an array of integers because we're getting back this contents of mapping that list. So let's go ahead and take a look at MakeGetRequestList. So here's MakeGetRequestList. We have the REST template, the URL, and the class, which in this case is an array of type T. This method is generic again. And now we're going to use a different method on REST template called exchange. And what exchange does is it takes the URL, it says, have this sent as a GET request, an HTTP GET request, and then make the return value be whatever we passed in as a parameter, which in this case will be an array of integers. So once it does that, it gets back something called a response entity, which in this case will encapsulate an array of type T. And then we're going to use that response entity, get its body by using the getBodyAccessor method, and then convert that into a list. So this is going to end up returning a list of the elements that came back, which in this case is a list of integers, and that's exactly what gets passed back from test list call. Note again that the main difference between test list call and test individual calls is that test list call has the server do all the parallel processing, whereas test individual calls has the client do the processing in parallel or not. And there'll also be a separate call for every element in the prime candidates list for test individual calls, but there will only be a single call here in test list call. And when we look at the performance results later, you'll see how those things actually pan out in terms of a win or not a win.